Did you ever interact with John Conway?
I used to see him fairly often during the summers. He was a very constant visitor of Neil Sloan when they were working on sphere packing and coating. And he would come up. He's a very interesting, unusual guy. If I had one word to describe him, I'd say he's surreal. Surreal. So he's interested in kind of physical things too. So I taught him how to take a hanger, and you can kind of stretch it so it makes kind of a square shape, and balance a penny on the end of it, and then spin it around, the penny doesn't fly off, and then stop it. And stopping is kind of the hard part. He really was fascinated by that, so he practiced like crazy, and he actually got pretty good at spinning it horizontally, which is harder. And I was into boomerangs at the time, so I was taught him how to throw a boomerang, and he started carving his own boomerangs. Now, he had a stroke not so long ago, and he said he couldn't do the penny on the hanger anymore. I said, well, try it with your left hand. He said, I tried. I couldn't do it. So it's kind of maybe it goes the opposite direction, right? No. If you say people are one of a kind, definitely Conway is one of a kind. He's a very interesting guy. We have one joint mathematical publication. So it was a problem in the American Math Monthly. They kind of generalized one of these unusual nonlinear sequences. In particular, it's easy to explain. You take a sequence that depends on the previous two values. So xn plus 1 is equal to a fraction. On the top is 1 plus x sub n plus 1, and on the bottom x sub n. So that's how xn plus 2 is defined. And then you just start it and you see what happens. Well, it turns out amazingly it has a period 5. It's periodic with period 5. And we have a problem that generalizes that to something that has an arbitrary period bigger than 5. And what happens in the middle, it gets really complicated, and then it kind of amazingly simplifies. So that was our problem. That was the problem in the monthly.